สวัสดีครับ This is a chapter 5. For this chapter, we will learn about the serial and parallel communication. The objective, after we learn in this chapter, you will understand the conversion from the parallel data to serial data, or convert from the serial back to the parallel data communication. And you will recognize the advantage of the serial communication. And I have a C code to simulate on the 74595 files. That is a ICs to convert from the serial to parallel. This is a simulation on the Arduino in the online GDB. Finally, I show you the virtual machine, Windows XP, and drawing the circuit in the Visual XP. So maybe for the last topics, maybe I will move it to the laboratory. I think it is not laboratory in this week, for the 2 or 3 weeks later. Okay, now there are the topics today. The first topic, we will talk about the serial and parallel communication. Here in this is between the serial and parallel communication comparison. On the left hand side is parallel communication. I suppose I have a computer connect to another device or external device. This is a connection and data sent as bidirectional. That is a two-way directional. That is sent or received in the same cables. And the data, I suppose, is 8-bit data. So we will have 8 cables, a cable. But in each cable is sent the bit 0 or 1 from computer to external device. Speed is depend on frequency send the data from the computer to external device. If you send in about 1 gigahertz, so you can send 8 bit, 8 gigahertz. This is a billion, 8 billion bits per second. This is a 1 gigahertz. For the 1 megahertz, maybe send is 8 million bits per second. Okay, on the right hand side here, this is a serial communication. The serial communication is used only 1 cable. So here have only 1 cable. But the main point in serial communication, both sides to the sender or receiver issues have a module for convert from the parallel to serial or serial back to parallels. Here, this module, this is convert from parallel to serials, and at the receivers or the external device is have a module convert from the serial to parallel. Here, the serial communication usually 1 cable. So the modules is convert from the parallel data and send it in a sequence of the data. For the serial communication, in the main point is have a starting bit and stopping bit to indicate the start data and end of the data. Here on the next picture, I suppose this is a data inform the graph of the data. The data have a start bit here and stop bit here. Inside the data, this is a data body. The data body have bit parity. Could you remember the bit parity that is we learned in maybe the chapter 2 about the bit parities. So the system use a bit parity to check the data and do the error correction. Here, this is a start bit and stop bit. When compare about the data between the serial and parallels, So the serial have overhead. What is an overhead? Overhead, this is an addition the data. Here the data have only 8 bit, but it have a starting bit, parity, and stopping bit. So the number of bits when sending in a group of the data is close because it have a set header in the starting bit and stopping bit. Now for the serial and parallel communication, not only the difference in the data transformation from parallel or serial, but in this point I show you 3 measures that is related to the effective compare between the serial and parallels. The first we will talk about the production cost. Production cost when you produce a device that is sent in the serial or parallel, you should consider the cost of making the product. And the second, we will talk about the parallel power consumption. Power consumption is some students feel serial or parallel take the same power consumption, but really it is a difference. And finally, we will talk about the noise protection in the serial and parallel communication. Okay, now we will move to this topic about the production cost. The production cost is a cost when you create a project or any product to connect to a computers or connect to another device. Most of the IoT device today is used in the serial communication, but in the very old device is used the parallel communication. And also inside the motherboard is the computers. In the motherboard in your computer use a parallel communication to send amounts of tons of the data to from the CPU to the I/O device inside the motherboard. But it is a connection between the motherboard to the VGA card to the USB. It is a serial communication. Okay, now move to the main point about the cost of production. On the left hand side, I suppose I have 8 cables. We know a cable is made from copper or sometimes use aluminums or irons. This is made to the cables. I suppose I have high quality cables. That is high quality mean the high conductors materials. I have 5 meters, so I think one cable is spending 12 baht per cables. So we have 8 cables. 12 times 8 is 120 baht, because this is a data communication cables. In the serial communication, have a module convert to parallel to serial and serial back to parallels. And the high quality cables is 5 meters. One cable takes 12 baht. And for the module, this is an IC and digital circuit convert from the parallel to serial. Each module, I suppose, is about 10 baht per module. It have 2 modules for connect to parallel to serial and serial back to parallel. Totally, its cost is only 32 baht. The cost is the growth in exponentials when your communication parallel in very high bit system. Example, in system I suppose you create a system about 32 bits. 32 bits is 32 cables. So of course the cable is very expensive. Could you remember very old hard drive that use the ATA communication? ATA communication, not serial ATA. This is a parallel ATA. This is a very wide cables, very wide cable, and have about 40 cable inside. So this is a expensive for cost in the cables. And today, all of the devices move to the serial communication by the reasons of the cost of the production. In these examples, I show you here. This is a project, and this is a protoboard project. This is a prototype board. A student solid the cable connect to the IC to another device in the parallel here. Have a lot of cable cross over on the motherboard, and here in this is on the back hole here, back circles, not back hole, back circle here. This is a parallel communication, and here this is a project in the serial communication. You look, this is have a few cables connect from the Arduino to the display board, Arduino to the sensors. Yeah, this is sensor, and Arduino to the, I think this is I/O extension. I/O extension is totally use a few cable and look simple to connection or building the circuit. Now we will move to the second topic about the power consumption. For the power consumption, maybe I show you in the simulations, because before I explain the circuits. So if possible, you open the Fingercat application, Fingercat on the website here. Click and type Fingercat here. And this is a Fingercat with application. You can simulation a digital circuit or electronic circuit on the Fingercat, and then you log into the Fingercat. I use a personal account, and here okay, yeah, this is my account. Maybe I have designs. Maybe a circuit is not show or circuit. Yeah, this is a full switch. If you have a time, you can put a device and build a circuit like this. Okay, now I will simulate this circuit, show you. And here this circuit have power supply here, and I have 4 resistors. Each resistor is a 220 ohms, and I have switch, slide switch, and LED. We know the LED is a spend about take a current about 30 milliamps mostly. Okay, now I simulate. Look here, I don't turn on any LED. The current spending only 0 amp, and now I turn on here. This is a 13.5 milliamp. Turn on here. It goes. This is a 2 times. It's going up, and here. Why I show you 4 cables? Because during sending data in the parallels, Parallel use many cables in system. Between send the bit 0, 1, 0, 0, 0 to the another device. It have take more powers. When bit on or here, when I press on or bit here, it take maximum 54 milliamps. It take more powers. Moving back here, and I suppose send is in serial communication is take only 20 milliamps. For X cable is take maximum as 240 milliamps. That is related about the power consumption. Okay, some students ask me, I sense is 1 bit, but one cable, but I send is X bit times. So when you think about the 8 bit time from the serial and parallel, when totally maybe it is about you think about a power peak. What is a power peak? During this is all of this is turn it on, its peak at 240 milliamps. But if you send is only one cable, its peak only 2 milliamps. For the power peak, it is related to the power supply to design the power supply for supporting the peak currents during sending the data. Okay, now we move to the next slide to the topics about the crosstalk. Here now we talk about crosstalks. What is a crosstalk? Crosstalk is an interference. That's when you when you're being a cable close to another cable, and the cable have some cable example in power transmission lines. Maybe it's generate a magnetic field around the cable here. So when you bring another cables to cause is the power cables, maybe it's interference or induce the current, small current to this. That will occur the signal or noise. So this is a conductor over cable create the errors, or no, not prevent. This is the create data, create error or noise in data transmission line, not prevent. Okay, now I will show you in this laboratory. So in the laboratory, we will bring an oscilloscope and bring a cable from the oscilloscope close to the another cable that's connect from the signal generators. You will see the signal from signal generator can induce to show on the oscilloscopes because it occur about the effect from the crosstalks. And how to protection the crosstalks? The first technique to protect the induce the currents, you can bring the cable by do the twist cables. Twist cable here. I suppose I have a cables and ground signal. This is a data and this is a ground. I twist cables. For twist the cable when I twist will occur the current loop here inside during the twist the cables in here. The current loop like as a circle here will do like as a reduce effects from the error or noise. By noise will delete it. Here this is a positive noise and this is a negative noise. Positive plus negative noise will be 0. So this is a like as a equation plus minus plus minus plus minus do the 0 0 0. So this is a will protect the noise. Example here, I have a cable and have a twist cables. When I do the twist cable, it will can reduce the noise from the high noise signal to the small noise signals. To show you what is the application that use the twist techniques, that is a twisted cables or LAN cable. When you look at inside the LAN cables have a cable and is a cable divided in 4 groups. Each group do the twist cable here to protect the noise. For making the very high protection, the high speed the data in LAN cables and expensive LAN cables is take aluminum foil here, cover another group of the cables to protect the noise. For another technique that is to protect the noise, use coaxial cables or shielded cables. Here this is a we call this is a coaxial cable used in the transmission. Inside is the data and have an insulation here and have a copper mesh. Copper mesh is a connect to ground to protect the noise. When noise hits to the mesh copper, it moves the currents to ground, not moving to the data inside. It's used in the transmission system. So the cables in the serial and parallels. When send is the serial communication, one cable line uses a 1 bit. So the product maker will make or bring a high performance of the good cable that have a twist and also have a protection in aluminum foil because the cost is not expensive. But for in the parallel communication, you have n line of the cable for n bit. So when you make a protection, when you're making a protection in parallel system, maybe you will do more or expensive for making a protections. Here it is a brick board or main board PCB layers. On the left hand side, this is a breadboard or student project board. Here, this is have a cable crossover and many cables. Maybe it's stainless the crossover between the cables and have a very noise in this cable. Why this project is a success? Because it is a run in very low frequencies, not very high frequency. When compared to the motherboards in computers, the motherboard run is over 1 GHz. So over 1 GHz, when you send it in parallel, you choose make many techniques to make a protection. Inside the motherboards here, in the PCB, usually the student think that PCB have only 2 layers, top or buttons. Not is the top and bottom layers. Inside have right as many pairs of PCB or many pairs of PCB pushed on here. This is have many layers. The button here, this is a layer in the first level is made from the copper layer to protect the noise, and the second layer, third layer and fourth layer. Inside the motherboards have a 4 layer or over 4 layers to protect the noise and protect the error or crossover between connection from the device to another device. Okay, now we will move to show. I will show you the technique convert from parallel to serials and serial to parallels. On this technique, this is a very simple by the concept. Example, I have a computer connect to an external device and send in the serial communication. Here, this is a technique inside the parallel to serial. And the computer will send it to the memory that is called a flip-flop memory. I have a memory 8 node 1, 2, 3, 4, 5, 6, 7, 8. And the bit data is a 1, 1, 1, 0, 1, 1, 0, 1. Okay, here the data put in each cell or each memory here. Now the concept do the chip left. What is a chip left? This is a chip the data. Chip the data from the first. The first data is is a one here. One this will move it out to the cables. Yeah? This is a cables. And I put 0 at the on the right here, and then move until move off all 8-bit cable 8-bit data. At the receiver part here is have a 8 memory cell. In each bit from the sender will write it to the another to the receiver part here. From the 1 bit at the top here, move to right in here, and do it the same 8 times until all data put it to the at the receiver part. Okay, then the receiver part or device is read it in the parallel to the system. So the communication is take 8 times for sending the data. For this is not cover about the starting bit, stopping bit, parity checks. I show you only a concept from sending data, not having a start stop. But in the real system, it have a start stop parity check in the bit sequence. Okay, now we will move to the last topic about show you the not the last topic. I will show you a 74595 IC in the original board. Here, this is a project connect IC to Arduino board, convert from the serial to parallel communication. You can buy this IC from the online marketplace. And example here, this is layout of the IC 74595. This IC have 16 pins, and the pins number 16, this is a power VCC, and pin number 8 is ground, and for the output pin is Q0 here to Q7 and the data sent to the pin number 14 and the pin name data SDS. For the OE is output enables, and STCP SHCP this is a bit sequence to control read, write, or start and stop sending. By look at SHCP, this is a bit for have a time or clock to send in each bit in the sequence. And STCP is send is when the data sending success. For the MR, I think it is a memory clear. Okay, now we look at the simulation. You can simulate it on the online GDB, and also you can write the code to the online GDB to simulate these projects. Here in this project, the connections here, the power supply 5 volts is connect to the IC, connect ground here, and it have one LED here. This LED will show the data sent at the DS input. When the DS send the data in sequence 10 bit, LED is turn on, turn off really fast because this is serial data in here. And when the data convert from serial to parallel, it show output to the LED around here in display in 8-bit data. For the data is sent by connect to pin 8, 9, and 10. Pin 8, 9, and 10 by the orange cable here. This is a data, and maybe SS or CP is a blue and bright blue here, Okay, and for the projects, after you build this project complete, here this is a source code. I will explain the source code. I know you don't learn about the C language, but I feel C language is very simple for students read the code. The C language here is have a two-part code. The loop is a main project, and here this is a function register write to setting the ICs. Okay, now the first part, this is a set up the output. Set up the output by set to output pin. For the latch pin, this is a pin number 9, and clock pin number 10 here, and data pin is pin number 8. And the communication setting the speed at 9,600 kilobit per second, and send the reset on the serial this is have a serial communication to communicate to user between running the program. Now in this course have a serial bit lead. It leads from the console or the serial communication box in the Arduino. When you press any keyboard or type a value, it will save the value in a variable bit to set here, and then this is a register for send the bit to the IC and make a delay 1000. Okay, here this is an example you try on this course, and maybe for the laboratory I don't have the IC. Maybe for 2 or 3 weeks later, if I can buy the IC, I will make the laboratory for you to run this code and test the concept for serial and communication connect to the Arduino to the IC or experimentation board. Okay, the last topic we will talk about the Windows XP in virtual machine. Windows XP is a very old operating system. Why I show you the Windows XP? Windows XP you can write the code and support some application in the very old application. For here, we have a FPGA board that is the can draw the circuits and program to the board. Running very good operating system on the Windows XP. It can run in the new operating system, but the system is installation and take more space on the hard drive. Is not proper or good for the laboratory in the IoT labs. So totally we use only Windows XP lab for test the concept program on board. Okay, for these experimentations, I will give you maybe in weeks 8 or 9 to program on the FPGA by write the circuit on the Windows XP. Okay, now we move to the summary. Totally in this chapter, I think you know the serial and parallel communication in main point. Please don't forget to concern about the production cost, power consumption, and cost talk that occur in the serial. That is when you compare to select serial or parallel in your projects. Okay, สวัสดีครับ thank you bye bye